Hello everyone, welcome to IIT Foundation classes. This is Srinivas, your maths faculty. Let us go to the topics we are going to cover in this academic year. Okay, so mainly in 8th class we are going to discuss about the topic of number system. So 6th, 7th, 8th number system topic is very important. Okay, next logarithms. I think this topic will be somewhat new to you. So simply nothing but we have discussed in earlier classes. I think so that you all learn about the concept of exponents and powers, right? Yes. So the exponents and powers, when we can change into the another form, is nothing but logarithms only. Where we are going to deal with the logarithms in this year topic. Next, quadratic equations. Quadratic equations and theory of equations both are related to algebra topic. One of the branch of a mathematics, algebra. Quadratic equations, theory of equations, both are related to algebra topic. We are going to deal these two topics in this year. Next, arithmetic progression. This is also comes under algebra topic only, but somewhat different to the regular classes. Arithmetic progression is also new to you, but it is not exactly new to you, because there are some standards or there are some basics in your regular textbooks which you couldn't find it. Okay, right. Arithmetic progression. Then plane geometry. Plane geometry is nothing but related to geometry topic only. Here in this year we are going to deal with the topic of geometry like triangles and concurrent lines, centroid, orthocenter, circumcenter, incenter, excenter. We are dealing with these topics this year in plane geometry. Next, sets. Sets and relations are these are the concept which is useful to your intermediate syllabus, nothing but functions. To identify, to solve the topic of a function in your further classes, the sets and relations are very useful to you. Next, coordinate geometry. Coordinate geometry is somewhat different than the regular classes. I think 8th class, yes, you know some base, you got some, you'll get some basic information in about coordinate geometry in 8th class, and 9th class you will come to know what is coordinate geometry. So these are all the topics which are useful in your present classes and further classes also. Okay, just look at it. Number system, logarithms, quadratic equations, theory of equations, arithmetic progression, plane geometry, sets, relations, and coordinate geometry. So overall 9 topics we are going to deal with this year. Okay, right. And each and every topic has their own priority. They are all important topics which is useful to your further classes. Okay, right. Now the today topic is nothing but number system. We are going through the first topic as it is number system. Okay, right. In number system, what are the topics we are going to cover in this year? So mostly when you have an 7th class textbook or 7th class material of our institute, the number system, we covered standard form of a number, first topic. I think that topic you have already come to know in our previous class. Standard form of a number. Okay, no? Standard form of number. Next, LCM and HCF. How to find the LCM and HCF in algebra topic. That means while you are taking that algebraic terms, how to find their LCM and HCF. Okay. Next, in this year, you will come to know Gauss theorem, Fermat's theorem, Wilson theorem, and the concept of unit digit. Okay, Gauss theorem, Fermat's theorem, Wilson theorem, and concept of unit digit also. Concept of unit digit, and we'll deal with the topic of rational numbers, and greatest integer function. Greatest integer function. You'll come to know about the greatest integer function, and you'll come to know about absolute value of a function, absolute value of a number. Next, intervals concept also introduced. Okay. So mainly these topics we are going to discuss in this 8th class. Okay. Now let us go through standard form of a number. Okay. Right. So let us continue the concept of number system. So first one, standard form. Okay. So let us see some set of numbers which are useful in the day-to-day life. Okay. So nothing but let us discuss about the natural numbers represent with the capital N. Natural numbers means the counting numbers are called natural numbers. Usually count from 1, right? So 1, 2, 3, 4 and so on. Counting numbers are called natural numbers, and the smallest natural number is 1. We start counting from 1. So least or smallest natural number is 1. And what about the largest natural number? The largest natural number cannot be defined. Largest number cannot be defined. Okay. Next, second set of numbers, whole numbers. Whole numbers are nothing but the natural numbers including 0. The natural numbers including 0 are called whole numbers. Like 1, 2, 3, 4 and so on. These are all natural numbers. The natural numbers with 0 are called whole numbers. Now can you say the smallest whole number? Smallest whole number is 0. Smallest natural number is 1. And what about the largest natural number? Cannot be determined and cannot be defined. Same way, largest whole number, this is also can be defined. Okay. Next set of numbers are nothing but integers. Integers means all positive numbers. All positive numbers means natural numbers. All negative numbers, natural numbers with negative symbol, minus symbol. All positive numbers, all negative numbers including 0. That means according to the definition you should identify that 0 is neither prime nor composite. 0 is neither prime nor composite. These are all positives. These are all negative numbers, and which is not a positive number, not a negative number. So neither positive nor negative. Okay, 0 is neither positive nor negative. Clear? Yes. So natural numbers, whole numbers, integers. Now after the integers, you should know some operations on integers or properties of integers. While you're taking any numbers like set of numbers like natural numbers, whole numbers, integers, rational, irrational, real or complex numbers. If you take any set of numbers, you should understand that these are all set of numbers having same properties. Same properties are going to be applied. Nothing but closure property, commutative, associative, distributive properties, and additive identity, multiplicative identity, or additive inverse, multiplicative inverse, inverse property and identity properties. These are all same for any set of numbers. Okay, we'll discuss the properties of set of numbers are different in another class. Let us go through the concept of prime numbers and composite numbers today. Okay, then we'll go through the standard form of a numbers, number of divisors of a number, or number of factors of a composite number, sum of factors of a composite number, and product of factors of a composite number. This is the very important topic related to number system. So by using this number of divisors, sum of divisors and product of divisors, we can make our calculations easier. Okay, na? Right. So before the standard form, let us go through prime numbers and composite numbers, but after the definition of factor or divisor. Okay, so simply I can explain the factor and multiple both with the same by taking a same example. Okay, so let me take an example like 7 5s are 35. So I am taking just one of the multiple of 7 or one of the number in or one of the number in 7 table. Okay, what is this? 7 5s are 35. We can also write it as 5 7s are 35, because I am saying that it is a 7 table, but some of them can say it is 5 table also. Yes, obviously both of them are correct. I am choosing it as 7 table because I have written first as 7, so I am telling that it is a 7 table. But you can write 5 7s are 35, that is also correct one. So 7 table, 5 table, both are same here. Okay, now while you are observing here, 7 and 5 when multiply each other, both are multiplied. 7 into 5 or 5 into 7. Answer is same. That means when you multiply two numbers, the result is called product. Am I right? According to the arithmetical operations, while you are observing clearly from addition, subtraction, multiplication and division, there is a formulas will be there. Add and plus add and equals to sum. That means when you add two numbers, the result is called sum. Here, what are the numbers we are adding? That numbers are called addend. Addend plus addend. For example, 7 plus 5 equals to 12. Here 7 is called addend. Addend plus addend equals to sum. Same way, minus minus subtrahend equals to difference. Minus minus subtrahend equals to difference. Multiplicand into multiplier equals to product. So this is called multiplicand, multiplier, whatever. Now coming to the factor here, when you multiply two numbers, these two numbers are called factors of the product. These two numbers are called factors of the product, and the product will be multiple of these two numbers. That means 7 and 5 are factors of 35. 7 and 5 are factors of 35 because 35 is coming in 7 table as well as 5 table. And 35 is multiple of 7. 35 is multiple of 7. 35 is multiple of 5 also. Okay, na? That means simply when two numbers are multiply each other, each of the number is called factor to the product. Each of the number is called factor to the product. So I am writing the definition here. When two numbers multiply each other, two numbers multiply each other, each of the number is called factor to the product. Same way, the product will be the multiple of these two numbers. Same way, the product will be the multiple of these two numbers. Okay, na? Right. Now coming to prime number, because the prime numbers are defined by using the factor concept only. So simply, what is prime number? Prime number is nothing but a number having exactly two factors. A number is having exactly or only two factors are called prime numbers. Okay, let us see. So prime numbers, as I given the definition, like a number having exactly two factors. Number having exactly two factors are called prime numbers. More than two factors, composite numbers. Okay, na? Number having exactly two factors are called prime numbers. More than two factors are called composite numbers. Okay, right. Now let us check the prime numbers from 1 to 10. I am taking the set of natural numbers 1 to 10. 1 to 10 numbers I am taking. Among these 10 numbers, which numbers becomes as a prime number, which are act as a composite number. Okay, let us see. Now I am checking each and every number from 1 to 10 by all the tables. So starting from one table. One table will come, 1 ones are 1. Still any other table 1 will come, 2 table 1 will come, 2 ones are 2, 2 ones are not 1, 2 ones are 2, 3 ones are 3, 4 ones are 4, but 1 will come in only one table, 1 ones are 1. Okay, coming to 2 table 1 twos are 2, 2 ones are also 2, 1 twos, 2 ones both are same. Okay, any other table 2 will come? No, definitely won't come. Now 3, 1 threes are 3 ones, 1 threes are 3 ones are same, so only 1 and 3. 3 will come in 1 and 3 tables. Now what about 4? 1 table 4 will come, 1 fours are 4. 2 table also, 2 twos are also 4. 1 4 is 4, 2 twos are also 4. 3 table? No. 4 table 4 ones, 1 fours 4 ones are same. So 1 table, 4 table, 2 table. Now 5. 1 fives are 5. 2 table 5 will come? No. 3 table, 4 table, 5 table won't come. Okay, 5 table 5 ones are 5. 1 fives are 5 ones are both are same. So only 1 table and 5 table. Now coming to 6. 1 table 1 6 are 6. 2 threes are also 6. 2 threes are 3 twos are. 4 table 6 won't come. 5 table 6 won't come. 6 table 6 ones are. 6 ones are 1 6 are same. So 1 6 2 3. The number 6 comes in 4 different tables. 4 tables or 4 factors, whatever. Now 7. 7 will comes in only one table. 7 ones are 7. Now coming to 8. 1 8s are 8. 2 table 2 fours are 8. 3 table 8 won't come. 4 table 4 twos 2 fours are same. Complete. Repeated now we can stop. Now 9. 1 9s are 3 threes are. That's it. 3 3 both are repeating. Yes. Now coming to 10. 1 10s are 2 5s are 10. Yes. 3 table 4 table 10 won't come. 5 table 5 twos. 2 5s 5 twos same. Now coming to here. Now check. 1 in how many numbers it is coming? How many tables? Only one table. Both are same. We should take it as only one time. Both 1 into 1. 1 into 1 1 only. One number. So 1 is having only one factor. What about 2? 2 is having two factors, 1 and 2. 1 and 2 are different numbers, 2 factors. Here how many factors? 2 factors. Now this one, 1 and 3, again 2 factors. Now 1, 2, 4. 4 is having 3 factors. Now here 1 and 5, only 2 factors. Now here 6 is having 1, 2, 3, 6. 4 factors it is having. Now 1 and 7, only 2 factors. 1, 2, 5, 10, 4 factors. 1, 2, 4, 8, 4 factors. 1, 3, 9, 3 factors. 3 different factors. Okay, no? So the numbers having exactly, according to the prime number definition, a number having exactly 2 factors are called prime numbers. Exactly 2 factors means here 2, only 2 factors. 3 is having only 2 factors. 4 3 factors over here. 5 is having only 2 factors. Next, yes, 7. 8, 9, 10 having more than 2 factors. So these numbers are called prime numbers. These are the numbers are called prime numbers from 1 to 10. Now coming to composite numbers. What are composite numbers? Composite numbers are nothing but number having more than 2 factors. More than 2 factors are called composite numbers. Exactly 2 factors are called prime numbers. Okay? Yeah. Composite numbers, that means more than 2 factors. Here only one factor. we have already taken it as a prime number. 2, 3, 5, 7 prime numbers. Now let us go to 4. How many? 1, 2, 4. 4 is having 3 factors. 3 factors means more than 2. More than 2 means composite number, nothing but first composite number in the set of natural numbers. First composite number in the set of natural numbers. Now coming to 6. 6 also a composite number, more than 2 factors. Next 8. 8 also a composite number, 9 and 10. But what about 1? 1 is having only one factor. 2 factors we have decided, that is, it is a prime number. More than 2 factors is composite number. What about 1? Here you should write that 1 is neither prime nor composite. 1 is neither prime nor composite. Okay? 1 is a neither prime number nor a composite number. Clear till then? Yes. So 1 to 10 there are 4 prime numbers, 5 composite number, 1 is neither prime number nor composite number. And also once check all the prime numbers after 2, 2 after 3, 5, 7. Now see here 4, 6, 8, 9, 10. So only 2 is even number, 3, 5, 7 are odd number. What is even number? A number which is exactly divisible by 2 table. Exactly divisible means without leaving any remainder. Without leaving any remainder. That means remainder should be 0. Such type of numbers. The numbers which are divisible by, exactly divisible by 2 are called even numbers, nothing but multiples of 2. The numbers which are coming in 2 table are called even numbers. The numbers which are not coming in 2 table are called odd numbers. We can say in another different ways. Okay, right. So prime number and composite number. So I found that 1 to 10 there are 4 prime numbers. 1 to 10 there are 4 prime numbers. You just try to find the prime numbers 1 to 100. 1 to 100, how many prime numbers are there? How I am doing this problem? 1 to 10, how I am checking like each and every table. So try to check for remaining also. That means 11 to 100. How many prime numbers are there? I am giving you the answer, that is 1 to 100. There are 25 prime numbers. 1 to 100 there are 25 prime numbers. Same way 1 to 50 there are 15 primes. 1 to 100 25. 1 to 15 50 prime numbers. What about 50 to 100? 50 to 100 is 10 primes. 10 plus 15 25 primes total. So try to write all 25 prime numbers at your home by using this method. Okay na? Check each and every table and identify the prime numbers. Everyone should get that 1 to 100 prime numbers without checking every time. You should by heart it. Will be useful in our further classes and any calculation part also. Very, very important. Okay? Right. So this is about prime numbers. Now coming to the topic of standard form of a number. Standard form is nothing but if you take any composite number. We are discussing about the prime numbers and composite numbers, right? The composite number, if you take a composite number, that composite number can be expressed as product of primes. This is called fundamental theorem of arithmetic. What do we call? Fundamental theorem of arithmetic. That means every composite number can be expressed as product of primes, nothing but its standard form. Standard form of a number. Standard form of a number. Okay? Check. Every composite number can be expressed as product of primes. Product of primes means, here you should understand that the prime factorization is also unique. Okay? So if you take any composite number, we can write it as product of prime numbers, and the prime factorization is unique. Let me tell you how it is unique. For example, I am taking 30. Try to find the prime factors of 30. Like 2 table in 30 15 times. 2 15s are 30. Now 2 table 15 won't come because 15 is not an even number. Now 3 table 3 5s are 15, 5 ones are 5. So this is the way I am doing, like 30 is nothing but 2 into 3 into 5. I am getting the prime factors 2 into 3 into 5. The same number 30 I can take directly 3 tens are 30. Now 5 twos are 10, 2 ones are 2. So here first I have taken 2 table, then 3 table, then 5 table. I have follow one order, but we are no need to follow the order to find out the prime factors. There is no rule to follow the order every time. So some of the person can do like this. That means 30 is nothing but 3 into 5 into 2. 2, 3, 5. What are the numbers? Are same numbers are being here. That means order is different, but the prime factorization is unique. That means what are the numbers I found while I am doing 2 and 3 and 5. The same numbers I am getting by doing like this, by taking the first one as 3. Okay, same numbers are being presented here. That means prime factorization is unique, but the order is not necessary. Okay, right. Now let us see, according to this one, every composite number expresses product of primes means I am taking a composite number as n. N is nothing but a composite number here. Consider n is composite number. It is not a set of natural numbers. That's what I am telling you and mention you clearly. Here n is nothing but a composite number. I told you which is expressed as product of primes. P is taken as prime number 1, prime number 2, prime number 3 and so on. Different number of primes, 10 primes also can become. That is completely depend on composite number. Okay, how many prime numbers does a composite number has? It doesn't have any rule. Am I right? A composite number can have more than 2 factors. More than 2 factors means 3, 4, 5 up to 100. The total number of composite numbers are not fixed for any composite number. There is no rule for it. But we should understand more than 2 factors, more than 2 primes, more than 2 factors composite number. So here P1, P2, P3 are composite prime numbers, and N1, N2, N3 and so on. That means the same number can be, the same prime number can be repeated for a factor as a composite number. That means this is the formula for standard form of a composite number. It is expressed as product of primes with different exponents, N1, N2, N3. Okay.